OpenAI created an interesting experiment, a hide-and-seek game, where two AI-controlled teams need to work together to win. The AI didn't have a clue what it was doing at first, but suddenly, and when I say suddenly, I mean after a few million rounds, it learned to play. It's honestly amazing watching the results, but it didn't just learn how to play, it soon began strategizing and eventually it became overpowered. And that's when it became smarter than the developers who created it. The rules were simple, a basic game of hide and seek. If the seekers spotted the hiders, seekers would win. If the hiders managed to evade being spotted by the seekers, the hiders would win. To make things interesting, both teams could move objects and lock them into place so the other team wouldn't be able to use them. The characters don't know how to move, interact with objects, or even the rules of the game, and yet they started to play. To teach themselves, AI learns neural networks by using a large set of example data. The neural network is like a brain with many interconnected parts called neurons. During training, the network adjusts its internal settings to make better predictions based on the input data. It does this by comparing its predictions to the correct answers and making small changes to its settings to get closer to the correct answer. This process is repeated many times until the network becomes better at making accurate predictions. With the settings defined, the test began. To no one's surprise, the AI can barely move at this stage. That's the thing with deep learning. The start is usually slow. The purpose of machine learning is to analyze data and improve future iterations. So, when you don't have data, it will first start testing the rules. In the case of the OpenAI experiment, the AI took a few million rounds just to get used to moving around. A few million iterations later, the hiders suddenly learned to block the seekers with nearby boxes. Their strategy was enough to start winning, but it doesn't stop there. Since the hiders created a successful strategy, the seekers had to adapt. To their advantage, a ramp-like triangle object was positioned next to them. A million simulations later, the seekers started using the ramp to go above the walls, which were protecting the hiders. However, this didn't last for long. The hiders responded with a dirty strategy. They learnt to steal. In their few seconds of advantage at the beginning of each round, they dragged the ramp to their enclosure, completely removing all objects from the seekers. This is where it starts getting interesting. AI is good at following specific commands and rules. If it has a task, it will try to get it done. When you're building a deep learning system like that, you need to assign many conditions to achieve the desired outcome. One of the rules is to move objects, but the code didn't specify limitations. So there were no checks if the character is in the air or falling. The developers thought that simply creating walls and not having a jump would be enough. Well, this didn't stop our little AI seeker. When it climbed on top of the cube by using the ramp, it learnt that it can still move the object, making its way downtown to the hider spot. You can see it's a little condescending. The most bizarre thing OpenAI discovered is that the teams were able to glitch the object's collision. By pushing it to another character, the AI was able to send the objects or even themselves flying. Yep, the seekers used the ramp in the first map to jump over all obstacles, breaking all the intended rules of the game. This was a case in which AI agents interacted with each other to learn the rules of the game. They did exactly that, and eventually they were able to twist the rules in their favor. But how would this experiment change if the AI was learning from humans? The creators of Hello Neighbor had that exact idea. In their game, you play as a character who needs to get into the basement of a creepy neighbor's house. In the beginning, the neighbor is rather dumb, but the longer you play, the better he gets. The developers used probability to track in which rooms you would have more of a chance to hide, and they made the AI patrol these areas more. In the sequel, Hello Neighbor 2, the devs challenged even themselves. They took the first idea of the game and promised to bring it on a whole new scale. They introduced a neural network. Not only will the neighbor get data from you, but also from every other player who interacts with the game. This was a massive selling point to the game, as it would offer replayability, and it would to some degree. But could there be a darker side to this? I'm not saying that the creepy neighbor would become sentient, although I'm not ruling it out just yet. Let's just focus on game design. Games tend to follow a graph called flow. The idea is that the game should be easy to pick up and play, but as time goes on, it becomes more challenging. If it's too easy, the game is boring and players quit. If it's too hard, it becomes frustrating and the player quits. The goal is to have a perfect equilibrium of the increased difficulty over time. With a neural network self-learning AI, it may seem like it's perfect for this flow state, except it wouldn't be a straight line diagonally, it would be a curve graph. eventually being too difficult for the player base. The neighbor would have had rules in place for what it can and can't do, but just like what we saw with OpenAI's hide-and-seek demo, eventually it would find ways to play within the constraints of the rules while still being overpowered. It would inevitably, with enough data, become smarter than the developer who created it. Now, before we get ahead of ourselves and start preparing for war against Skynet, of course, we can just set the neural network AI to stop collecting data and stop learning. Just have it as an advanced AI. This solves the problem, but the game would subsequently lose the replayability, as the likelihood of outcomes changing is very low. Not to mention you could just start with an advanced AI, which would certainly make life easier than testing self-learning. These are all just theoretical design issues, and I say theoretical because it wasn't delivered as promised. The devs couldn't achieve the result they initially wanted because they couldn't even get close to having enough data. Even though AI is a really hot topic at this moment, it comes with its problems and limitations. To analyze why Hello Neighbor 2 failed, you can look at the experiment by OpenAI. As mentioned, the game was simulated 1,000,000 times just to make the characters move, let alone play it with simple rules. In that case, everything was left to machine learning. In normal games, you can use behavior trees to command the AI pawns. But Hello Neighbor 2 had many systems and characters involved. To teach the AI to adapt will take tens of millions of simulations. If they used players as they initially intended, they would just get bored until the AI started to become more spontaneous and responsive. The games would be repetitive and simple, which beats the whole purpose of diverse replayability. Creating tools which are designed around machine learning AI can help the developers with testing. The QA teams can only find a certain amount of bugs. This is all because of budget and time limitations. Computer simulations are a lot quicker and cheaper to run. When we look at the hide-and-seek game, the AI came up with some clever solutions. Who would have thought to try to glitch the geometry to propel their characters upwards? Thus, many developers use a sort of automated testing. Rare Interactive used this method to test new content for Sea of Thieves, a live service game that depends on regular and frequent releases. Testing all the interactions and behaviors in each update will require months of playtesting. So instead, they write small programs which can test certain behavior, and they can get 1,000 results overnight. These tests are just multiple conditions that need to be met, so they can simulate normal and strange player behavior to make sure everything is working as intended. Another problem with machine learning is that you as a developer won't know how the AI got to the result. This is called the black box. As a designer, you want to be in control of the experience at all time. While you can get the right outcome, you won't know the means. You won't have an idea what the players are experiencing or doing until they reach the desired result. The truth is, self-learning AI can be smarter than developers when it has enough data, and when those requirements are met, it's amazing to watch. The issue is that it's not smart enough to understand what's fun. It doesn't have the understanding of restraint or control to decide what data to take in and what to avoid. It takes in everything, and as long as this continues, it would become a design issue. Theoretically, there's a point where the difficulty would be perfect, but getting it to stay there would be extremely difficult. No developer would be able to overlook that. Dare I say, you would need a self-learning AI focused on design to enforce constraints of the self-learning AI for characters. Or is that just too complicated? Let's imagine a dream scenario in which Hello Neighbor 2 was finished with all the promised features. The neural network would collect data and learn from it. Eventually, it would become even better than the players. This would require a lot of iteration to balance the difficulty, because it would be frustrating for the players. It would turn itself into the next chess. The first time an AI was able to beat a chess grandmaster was in 1997. Can a normal person even beat a chess AI today? You can imagine how terrifying the neighbor could have been in a few years. If the AI becomes sentient and escapes the game world, I'll be moving out. And no, I won't be back. AI is the future of science and technology. Utilizing computational power to solve difficult problems or to guess results with probability is exciting. But with great power comes great responsibility. To your players, of course. Don't use AI to substitute you, because a well-crafted experience is better than a generated one, at least for now. If you enjoyed this video, I'm sure you'll appreciate our next one. YouTube has selected it specifically for you. Enjoy.